Okay, we're going on now to topic 1 of chapter 4. And we have a number of items to go over. And this will relate to equations that we did back in chapter 1. But in this case, it's going to be inequalities. So instead of being an equation, it's going to be an inequality, and we'll pick out the difference as we go on. So we'll work on solving them, interval notation that we've used before, the addition principle of inequalities, multiplication principle for inequalities, and then using them together, and then a few problems. Now, when we deal with inequalities, there are 4 signs that we will be working with. And the first one is, let's say this one. This is the less than sign. If we put a bar, which is sort of part of an equal sign with it, this creates less than or equal to. So there are 2 distinct signs, and we'll go over the significance of that later. And then this one, where as you go from left to right, the broad or opened end is toward the left. This is greater than, and then this is greater than or equal to. Now in the whiteboard video that I do, I have these up to the side of the board throughout the lesson so we can pick on them. An interesting thing about them is when we use them, and we're going to do what we call interval notation or graphing, these are placed on the graph and in interval notation in a certain way. In fact, if you want to take notes on it now, I'll go over it with you, and then hopefully you can pull this out of your notes. So if we had a graph, let's make some graphs here. And we were going to say that, let's say the number is 2 for all of these. And then this is our line, our point, right on that number line. And then we were going to graph this, that let's say x is less than 2. Well, is 2 included in that set of numbers? Well, the answer is no. So we indicate that by a parenthesis at 2. We darken this line, and we get an arrow indicating it's going on to what we call over here is negative infinity. Over here we have positive infinity. Now for this one we're saying it's 2 is less than or equal to 2. So now 2 is included in the set. So instead of a parenthesis which states it doesn't include the 2, we use a bracket which states it does include the 2 now, but the rest of this is all the same. And in this case, we're saying 2 is greater, or x is greater than 2, but 2 is not included, so our parenthesis will face to the greater side, and that goes on to positive infinity. Now this one, it's x is greater than or equal to, Well, we put a bracket because 2 is now included. So these are the graphs, and I could just put an X there actually. And over here, there's the number 2. And if you have that in your notes, this will be an excellent reference of what we're going to do when we have to graph them. Now, another thing we're going to be doing is putting it in interval notation. So how would I put this in interval notation? Well, in interval notation, we simply list what's on the graph, that it's coming from negative infinity. That's what's over here. And as we read it, it goes up to, put a comma there, 2, and 2 is not included. So this is interval notation for this graph. And then here, it's coming from negative infinity. And by the way, infinity, whether it's negative or positive, always has a parenthesis. But now we know 2 is included, so we put the 2 and then a bracket. I've always said that graphing it makes putting it in interval notation very easy, because you're just sort of taking this graph and putting it into this form. So this one now we'll start with a parenthesis for 2, and it goes to positive infinity. Again, infinity always has a parenthesis. And this one, a bracket, 2, comma, positive infinity. Okay, so this is something I would have had on the board, and I did on the whiteboard when I did this lesson. And that's some background. Okay, let's do this one. Determine whether a given number is a solution for x, and we can just take the negative 4. Negative 4 is less than 5. Is that true? Yes. Now how about 6 for over here? 6 is less than 5. That's not true. So no, that's not true. So again, some easy things, but there is background items going on. So there's the number line that we had mentioned earlier, that on a number line, anything to the left of anything to the right is going to be less. And when you see 6, 6 is not less than 5, because 5 is to the left of 6. Again, visualizing a number line is also a useful tool. Now, in this slide, they're telling us that when we graph inequalities, we don't want to have to list every single thing. The list would go on infinitely. So we draw a graph, or we use interval notation, or sometimes we use set builder notation. These are all things we've done before, and we want to tie them in. So interval notation, I just showed you, is a kind of a short way to indicate what your values are for the inequality. Set builder is very closely related to the actual expression, and we'll be doing that. And then interval notation, here they are reviewing what I put on that first slide. So if it's only a parenthesis, the numbers that they start with are not included in the set. Brackets indicate it is included in the set. And we'll have some practice on this. Now, generally, for solving inequalities, all of the rules we had in Chapter 1 for equations are true, especially for the addition principle. We can add something to one side, subtract something from one side, and it's still an inequality. So here they're asking us to solve and graph. So what we will do, take our 6 from this side, just transpose, and we get x is greater than -4. Because when the 6 came over, it became a -6. So we have a +2 and a -6 gives us a -4. Now, we'll go over a couple of things here. If we want to put this expression or this inequality into set builder notation, all we do is put a line there, we put an X there, and then we put braces. And you might say, is that all we need to do? And that's true. So this is, you read this as X is such that X is greater than -4. Now, the next thing we want to do is to graph it. So in your homework logs, you can just sketch it, that would be fine. And the number you're interested in is -4. So there you've put that on the number line. And it's X is greater. So now you think of what kind of symbol are we going to use? Well, when it's only inequality and there's no equal, it's going to be a parenthesis. And since it's greater, it goes in this direction. And there's the graph now of this inequality. And now we're going to put it in interval notation. Well, we're going to use a parenthesis. We pick up that number 4, -4, and it's going on to positive infinity. So there we solved it. We put it in set builder notation. We did the graph, and it's now in interval notation. So not too difficult. And again, hopefully you're taking notes so you see the pattern so that when you do your practice and your quiz-mes, you'll get it right on the first shot. So there's the graph. And they didn't put it in the other two, but that's okay. We're doing a lot of review. Okay, here they want us to solve and graph. A little more complicated, but we're going to use our same principles that we did when we solved equations. We're going to subtract 1x here, or transpose it. So this will become 3x over here. We're going to add 1. Our sign stays the same. And this becomes a -9. So we transpose the x. That became a -x. That gave us a 3x. Transpose a -1 became a +1, and a -10 gave me that. And now I'm going to divide both sides by a 3. And I get x is less than or equal to -3. Now to put this in set builder notation, I put a line, I put an x, and then I put my braces. That's set builder notation. Now to graph it, the number I'm interested in is -3. And what sign will I use here? A bracket or a parenthesis? Remember, it's x is less than or equal to. So this is going to be a bracket that faces this direction. There's your graph, and then now interval notation. It's coming from -infinity, going up to -3, and because of the bracket and the inequality sign, the -3 is included in the set. Okay, yes, 3 for the price of 1, so to speak. So they solve it, giving you the rationale over here. There's your actual answer. There's set builder notation. There's the graph. And we also added interval notation. Now, as we go on to multiplication, you recall when we introduced this, I said most of it is exactly the same. Well, here's the case where there is something a little different. And the difference is, I'll show it to you. Now we know that 2 is less than 4, isn't it? That's a true statement. And if I multiply both sides by 2, let's say, I get 4 is less than 8. That is still true. But how about if this were a -2? Now I'm multiplying each side by a negative. So -2 times 2 is a -4. And a -2 times a +4 is a -8. Now the question is this true? Is -4 less than -8? And the answer is no, that's not true. -8 is less. So when we multiply or divide by a negative, only this, in order to keep the inequality true, we have to change the direction of our inequality sign. Now when we read this, it's -4 is greater than -8. That's a true statement. And this happened because we multiplied by a negative. Or if we were to divide by a negative, the rule is, in so doing, we reverse the direction of our inequality sign to keep it true. And that's what they're saying here. Okay? And this is the proof of it. Okay, now for some of these, we may not have to do it, but let's keep an eye out for it. For number or letter A, I should say, here we have a fraction. So as we said in chapter 1, we want to multiply both sides, going to change colors here, by a common denominator, which happens to be 7. And this then becomes, the 7's cancel out, and I get x is less than or equal to 28. Is this true? Yes. And I don't have to do any kind of changing around. But notice here in letter B, in order to get y by itself, I have to divide by a -4. Now when I do that, in order to keep my answer true, you're dividing by a -4, you have to reverse the direction of the inequality. So this now becomes a y, and this becomes a -5. Only when you divide or multiply by a negative do you reverse the sign. Here we didn't, so we don't change anything. Here we did. And there's your answer. There's the graph, and there's set builder notation. Remember, all you had to do is put a vertical line right there, put another X, and then your braces. And then that's the point you're interested in, and because it's less than or equal to, you're using a bracket. And I like to stress this concept of it's coming from -infinity and here, because 28 is included in the set, you will use a bracket. Okay? Again, the graph is an excellent way, if you have a correct graph, to then change it to interval notation. And you'll be doing that on your tests as well. And your practice and quiz me. Now, again, since we have divided both sides by a negative, notice what they've done to the inequality sign. They reversed it. They make it a natural part of that. And there's the rationale. And there's the answer. Set builder notation, the graph, and then interval notation. Again, just taking it right from the graph, a parenthesis, a -5, a comma, and this is going to positive infinity. Again, if I'm going fast, I don't mean to, just hit the pause button, take any notes you want. In fact, you can reverse it anytime you want, and that's the kind of a good deal about this. Okay, let's solve this one and see what we get. So, we're just going to transpose the x. This will give me a 2x on that side. Transpose the -3. Our inequality sign stays the same. And this gives me a +3, so a 10. Going to divide both sides by 2. And I get 5. And then the graph will be a 5 here. What sign do I put here? A parenthesis. And let's write this in set builder notation. Remember, you just make a line. Put another X there, braces. And interval notation will be 5 and infinity. So this is sort of an easy one. We didn't have to remove parentheses or anything, no fractions, didn't have to change the direction because we didn't have to divide by a negative. And I like it. They're showing us all of the steps. Again, you can cut down on some of the steps. There's set builder, and we've done all that. Okay, this one deals with fractions. Now, by the way, there is a workaround for not having to reverse the sign of the inequality. And that workaround is take the negative term and move it to the other side. Keep the inequality sign the same, but now this becomes a positive 3.2x on this side. And then I have over here 15.4. Transpose this, that becomes a positive 6.76. So add these together. So when we add these together, we get 22.16. And now notice I'm dividing by a positive. So I don't have to change the direction of this sign. And I get x is greater than this. Now notice that a negative x is less than something. A positive x is greater than something. By moving it to the other side, in a sense, I change the sign. So a little insight. This is a workaround. Or had I left it on this side, I would have had to reverse the direction of the sign from a negative x being less than to what I have here, a positive x being greater than. And then putting it in set builder notation. All we have to do is this. And then graphing that and in interval notation. Now, one of the things they did here that I didn't do, and I did recommend this though, is to get rid of the fractions. That's fine. Another technique. Notice now they're dividing both sides by 320, but a negative 320, and the inequality sign gets reversed from less than to greater than, right there. And there's your answer. Comes out the same. Now, by the way, a useful thing is to get rid of decimals just for easier computation. But you see here, the answers come out the same. All right, let's do this one. You may have recalled that I often said try to keep your variable positive. Again, by doing so, you don't have to reverse the direction of the inequality sign when you're dividing or multiplying by a negative. Okay, because it's positive. So I'm going to distribute. I get this. I'm going to combine like terms. I get this. And I'm going to transpose the negative 2x to this side. Becomes a positive 2x. That gives me my 6x. I'm going to transpose the negative 3. That gives me a positive 3. And a negative 15 gives me my negative 12. I'm going to now divide both sides by a positive 6. And I get x is less than or equal to negative 2. Now, many of you may want to rewrite it that way. X is less than or equal to negative 2. Set builder notation, just put an X there, braces, draw a graph, there's negative 2. We're going to use a bracket because 2 is included in the set. There's our graph. And interval notation, it's coming from negative infinity up to negative 2, and negative 2 is included in the set. Wow. So this was one from chapter 1 again. Instead of an equal sign here, it was an inequality. And by moving this term to this side, I kept my x's positive, and I didn't have to reverse the direction of the inequality sign when I divided by a positive 6. Okay. Actually, they're doing what I did. They don't like to change that either. Okay. Again, since you're dividing by a positive, you don't reverse the sign. And there's the set builder, and we even gave you that. Now, for this chart, as we look at it, there are some important words. Is at least. This is greater than or equal to. Is at most less than or equal to. Cannot exceed less than or equal to. Must exceed is greater than. Is less than, that's straightforward. Is more than. Is between. This is one we haven't done yet. So this is a compound inequality that we see over here, where the m is in the middle, and no more than, less than or equal to, no less than, greater than or equal to. So again, pause this, look at them carefully, and this will help you in your setup of the inequality statements. So let's take a look at this, and I'll pause it as I set up for you. Okay, Lazer Lines charge $65 to go to a person's business, plus $45 per hour. Well, there's $45 per hour. We don't know how many hours. He is billed less than this. Well, there's your less than and 150. So there's your inequality. So how do you solve it? You want to know how many hours? It would subtract 65 from both sides. And this looks like 85 over here. Take 50 and another 15. Yep. Then we're going to divide both sides by 45. And this will be our number of hours. So we subtracted 65 from both sides. We divided both sides by 45. So the amount of hours, when I simplify this, in an improper fraction form would be this. In a mixed number form, it would be this. And then in decimal form, it's like 1.8 that repeats and repeats. Okay, let's look at it here. Similar. And there's that. Now, there's the answer, but what's the answer statement? And here they're saying just less than 2 hours. So just less than 2 hours, or 1 8/9 hours. Okay, you'll have plenty of practice. We'll be working on our booklets, and you'll be doing your practice and quiz me as we prepare for the test. But on this section, remember, we take 2 days, 2 class sections to do it. So we'll take our time, and actually this was one of our longest presentations.